Welcome back to Boiler Wild. My name is Eric Johnson. On this podcast, talk about boiler industry topics as well as personal development. Wild. You may be wondering if you haven't listened to other episodes. That's a weird name. It is an acronym I made up, and it's also a cool name. I at least think it's cool. So hopefully you do too, but WILD stands for work hard, invest yourself, lead others, and develop yourself into a person of excellence. We should always strive to get better. I always want to get better. And the work life, get better, the home life, it all goes together. So I am by myself today. I know I had a run of guests on the podcast, but I am by myself today. First of all, I would like to thank all the guests that have come on so far. They bring amazing insight that multiplies the value of this podcast, and hopefully y'all find it valuable. I would ask one thing from y'all. Please rate on your podcast app, whether it's Apple or Spotify. And if you're listening on YouTube, please subscribe to my channel. But if it's Apple and Spotify, please rate the podcast 5 stars. That really helps me out. And the more 5-star ratings I have, the better the search results are for when people finding the podcast. Just trying to get over 25-star ratings for Spotify and Apple. I don't have the numbers right now. I think I had 13 or 14 on the Spotify last time I checked, and like 10 on Apple 5-star ratings. So if you enjoy this podcast or any other podcast episodes, please rate it 5 stars. Goal is to get 25 stars on both apps. That would be amazing. I appreciate you all listening. So today I want to talk about an event that happened in 2024 at the very end, December 26, 2024, which seems long ago. It is now near the end of January 2026, and it's a little over a year, and the United States right now is currently freezing. So hopefully, if you're in the northern states or even in the southern states, it is cold. Hopefully people are not covering up their louvers with cardboard and setting up their boilers, and you will find that the plumber ran the freshwater pipe across the louver in the summer, and now that it's freezing, it causes all kinds of problems. But I want to talk about an event that, like I said, happened December 26, 2024. It happened in Camilla, Georgia, which is like southwest Georgia. And it happened at Tyson Foods, which is a business name, but it's essentially a Tyson chicken plant. And I believe most people have heard of Tyson chicken, probably the most famous, popular chicken manufacturer in the United States, at least. If you go to the grocery store, half the bags of frozen chicken are made by Tyson, but they have tons and tons of plants. This is just one of them. But there was a thermal fluid explosion that was initially reported as a boiler explosion. And I had made a post on LinkedIn about when it happened. And I looked it up and looked up that they had thermal fluid heaters and kind of looked at the Google Maps. And it didn't seem like it was an actual boiler explosion because of a fire. It had a pretty big fire in the area. And due to deductive reasoning and looking at other boiler explosion incidents, typically a boiler explosion doesn't cause a giant fire. It just causes a lot of damage. And really a boiler explosion, if it happens because of water flashing, there isn't really anything to catch fire. It's just a lot of energy moving around. Whereas thermal fluid heaters, you can catch the oil on fire, and that is what happened in this case. So I have the OSHA report from the investigation that happened. Unfortunately, one person died and 2 people were burned, and then I believe some other people had some minor injuries, but sad. Anytime somebody dies, that's obviously tragic. And it's even more tragic that they were a bystander and not even involved in the plant operations. I will get more into that, and I'll read about it in the OSHA report. But yes, I believe that incidents like this should be highlighted and other people should read about them. We shouldn't suppress them and be like, oh, that's bad press, bad news, because if you are a service technician, boiler operator, maintenance person, and you never hear about the bad, you end up believing that accidents don't happen anymore. And in 2026, that we're just super safe and nobody dies. And that's a thing of the past, especially with boilers. But this accident and other accidents like this do happen, and a lot of times they don't make the news, and the company where it happens, it's not big enough to like be on a national scale, but the company obviously doesn't want the bad press, so everything gets buried. It's a private company, and no information comes out or lessons learned. One thing I do love about lessons learned is the Chemical Safety Board. The U.S., it's a government agency, but the Chemical Safety Board, if you haven't already, go look up their YouTube channel. They are a government organization, federal government organization. It's a pretty small organization, but they exist to essentially help improve safety in chemical-related incidents, and that's loosely by chemical. They do venture outside of it. They did a great write-up and video on Lloyd Lang Box Company in St. Louis, Missouri, and the explosion of a tank there that ended up killing 2 or 3 people, I believe. And those animations are top quality and probably the best in the industry. Obviously, they get federal funding, but they hire an outside animation company and they seem to do it right, and they do a great job investigating because they are a federal agency, so they do get access to these accidents and they can do a proper investigation. And unlike OSHA, they're not there to point the blame and to fine people or fine companies. The Chemical Safety Board, basically their mission is to help others learn and improve safety by like lessons learned. And when you watch the videos, I mean, they have videos going back 10 years. And when you watch the videos, they will say, hey, this is kind of what happened, and this is what we recommend that could change. And if you have a similar situation, it gives you some perspective of what to think about and how things can happen. A very easy thing to get trapped into when you're thinking about something is a lot of people think that these big accidents at like chemical plants, boiler explosions, that there's like this one big decision that, oh, this person did something wrong and this goes bad. But it's typically a bunch of very, very minor, seemingly innocent actions that all stack on top of each other that end up being this chain reaction that ends up in a larger event that sometimes gets people hurt, sometimes doesn't, and then also sometimes people die. And the larger events where no one gets hurt or nobody dies, you get very lucky, but a lot of times companies can just think of that as a near miss and, oh, near miss, let's not do that again. But you have to really think about how lucky you got that nobody got hurt, nobody got killed, and how do we prevent that, and how do we change our actions. And it's just a different way of thinking, versus waiting for somebody to die and then or get seriously hurt. And then it's, oh, we're so sorry. Let's change our ways. You shouldn't have to wait for somebody to get hurt or to die in order to change your ways. And that goes with boiler safety. There's so many things that people do that are unsafe, but nobody ever really does like in action. Nobody ever jumps out of safety and says, you know what, when I jump this out, I'm going to cause this boiler to do this and it's going to cause this event and whatever. And then no, nobody ever thinks that an accident is going to happen to them. Just like you get in your car and you drive down the highway, nobody ever says, you know what, I'm driving today, I'm going to get in an accident. It's something that happens. Same thing with, it's a common thing in like fall protection, where a lot of people think that, oh, well, I will be able to catch myself before I fall. I will know when I'm falling and I don't fall. Falling happens to other people. Well, when you work around heights and you work around open ledges and you're not tied off and you don't have the proper harness and all this stuff, and all of a sudden you do that for 10 years and all it takes is one slip up and then you fall and you never went to work that day saying, oh, you know what, I'm going to fall today. But no, you are flirting against the danger and eventually it caught up with you. That is the same thing with boilers. And that's why I talk about a little bit that people need to maintain their calibration of what is safe and what is unsafe. And if you work in a very unsafe environment where safety rules are constantly pushed around and all this stuff, you lose your calibration of what is unsafe. And then when new people come into that environment and they don't know any better, they think those unsafe practices become normal and they don't really know any different until somebody tells them. And that is why it's so important to maintain the calibration of, hey, these are the codes and standards. This is how we do things. We're going to do things safely, and we're not going to compromise just because, oh, production's down or this and that. We have to do things safely, because the second we start deviating from what is safe and what is standard, we start losing our calibration of safety and we start normalizing unsafe practices, which it seems like there's no consequences, but the consequences will eventually appear. So anyways, Keystone Foods, Tyson Foods, Camilla, Georgia, Southwest Georgia, December 26, 2024. I'm going to read the OSHA report, and this first section is from the narrative report. This is essentially OSHA comes in and interviews people, and this is a very informal put together of what they think happened in the events. When the explosion occurred on site, a tractor trailer was parked adjacent to the boiler room while delivering supplies to the facility. A wall of the boiler room collapsed onto the trailer and a portion of the truck. The driver and their spouse were in the truck at the time. The collapse resulted in the death of the driver's spouse. The CSHO, which is a person's job title, was able to confirm to the driver's attorney that the driver was a 1099 owner-operator and not an employee of the trucking company. In addition, the attorney stated that the driver's spouse was not an employee and was accompanying their spouse to keep them company. It is determined that the fatality was outside the jurisdiction of OSHA. So, unfortunately, this driver's spouse was in the sleeper part of the cab of the semi, and when the boiler explosion, I will say thermal fluid explosion happened, it knocked down the preformed concrete walls of this boiler room, and the walls essentially fell over like dominoes, and it crushed the sleeper portion of the truck. But since the person was not employed by the company, OSHA doesn't really have jurisdiction over somebody dying because they are not, there's no employee-employer relationship, which seems heartless, but OSHA does have bounds of where they can operate. However, I am sure that the driver is suing the Tyson Chicken or Keystone Foods for whatever. I'm sure the lawsuit's probably still going on for negligent death or something like that. I'm not sure, but once again, very, very unfortunate. And it's even more unfortunate that this person just minding their own business, unassuming that they're next to danger, and then was unfortunately killed. So I hope that that driver can go on with life. I know that's hard, but that'd be a tough day. I don't wish that on anybody. So going now into what actually happened on in the facility. And this is a little bit of background to start with. The facility consisted of two main production areas, evisceration and further processing. The further processing area was used to batter, fry, and package chicken for retail sale. The fryers in the area were heated by 3 thermal fluid heater systems, also called boilers, located in a boiler room on the east side of the facility. 2 boilers were installed in 1997 and a third was installed in 2018. The boilers heated a heat transfer fluid, chemical name mineral oil, product name Paratherm NF, to a temperature of approximately 500 Fahrenheit at a pressure of 40 to 50 psi and was fed via pipes to the fryers within the production area. So a little bit of background if you don't know. So a thermal fluid system is essentially oil pumped through pipes that is heated, and people use this because you can get a higher temperature out of the oil versus a steam system versus the pressure. So every steam system you can look at the pressure temperature charts at 100 psi pressure, it's going to be this temperature. And when you need higher temperatures, 500, 600, 700 degrees, you end up with a very, very high steam pressure, which involves all kinds of risk and ups the cost of the boiler system and the operation of the boiler system, where you can instead install a thermal fluid heating system where you pump oil, and that oil can be heated but at very low pressures because it has a different boiling point, a much higher boiling point than like water would be. So in this case, the system was 40 to 50 psi. Systems can even be less than that. Everyone varies. The hottest thermal fluid oil system I've seen in my experience was like 800 degrees. And to get that out of steam would be a ton of steam pressure. I don't know it off the top of my head what 800 degrees is in steam pressure. But that is why people or companies use thermal fluid systems, and thermal fluid systems are very, very common in food production, especially with chicken, potato chips, so that they heat up these fryers to, in this case, it was 500 degrees. And when it says boiler, a thermal fluid heater is going to be built to Section 1 of the ASME Boiler and Pressure Vessel Code. So by definition, it is a boiler. And if you didn't already know, not every boiler heats water. So a boiler heats a fluid. Historically, it's been water, but by the actual definition, a boiler does not actually have to heat water in order for the vessel to be defined as a boiler. So in this case, the boiler, which is the industry term, is a thermal fluid heater, but by definition, by ASME, it's going to be a boiler. And if you looked at the ASME stamp on the boiler, it's going to have a S stamp, I believe, for Section 1 of the ASME Boiler and Pressure Vessel Code. So that's a little background. Getting back to the report. The boiler stayed in operation from Monday through Friday. On weekends and extended holidays, the boiler temperature was reduced to approximately 300 Fahrenheit in order to save energy cost. The boilers were not turned off completely so that the piping would stay warm and would not have to be brought up all the way back to 500 degrees Fahrenheit. Typically, the only time the temperature was brought down below 300 Fahrenheit was when a maintenance activity was required. 100-pound portable carbon dioxide bottles, 2 per boiler, were maintained and inspected in the boiler room for fire suppression purposes. All right, once again, background. So a thermal fluid heater is in this case, a vertical type boiler, but there's also horizontal ones, but they have coils. and the oil is pumped through those coils, which is heated by a flame. In this case, it was flame burning natural gas. And what can happen is the coil can rupture, or you can overheat the inside of the heater, cause a fire. And so it is common to install carbon dioxide suppression systems onto the stacks of the boilers. And when the stack temperature gets over 1,000 degrees Fahrenheit, the valve would open and pump CO2 into the stack and to the boiler, which would suppress a fire, which would get quickly out of hand. Because you really can't put an oil fire out with water. It's not that simple. You got to use typically foam or like a mixture. I'm not a firefighter. If you're in your kitchen and you have an oil fire, the last thing you want to do is put water on it. Water displaces the oil. The same thing with a thermal fluid heater. So carbon dioxide will be pumped into the heater. It'll suppress the fire. And that is just a safety, another level of safety for helping to keep a thermal fluid system safe and not burn down the facility. It's not required per se that I know of, but in this case, this manufacturer typically recommends it, and I'm sure it's just an option that companies can check that they want. Hey, we want a carbon dioxide fire suppression system for each heater. On Thursday, December 26, 2024, the refrigeration supervisor was called in while off duty because the boilers were off and the refrigeration maintenance staff on duty could not figure out how to get them started again. The boiler temperature had been reduced to 300 degrees Fahrenheit for the Christmas holiday, and the maintenance staff was attempting to return them to full operation. However, due to unknown malfunction, the boiler temperature had dropped to approximately 100 degrees Fahrenheit. The refrigeration supervisor found that a weld had broken on a bracket associated with pump number 1, causing the system to shut down. Pump number 1 was one of the pumps that fed the heat transfer fluid through the system. The refrigeration supervisor stated that he put the bracket back in place, welded it, put a new coupling on it, and started it back up. The refrigeration supervisor also stated that they performed an alignment during the coupling installation. The boiler temperature was raised in increments from approximately 100 degrees Fahrenheit to approximately 540 degrees Fahrenheit over the course of 1 hour. The refrigeration supervisor then called the production manager and asked them to start one fryer to put a load on the system. Then they observed the system to see how it responded. The system appeared to be functioning properly. Therefore, the refrigeration supervisor contacted the production manager and asked them to put another fryer online. The refrigeration supervisor stated that they decided to take a break since they had been working for 4.5 to 5 hours and left the boiler room. Approximately 10 minutes later, they were informed that there was a fire in the facility. Witnesses reported observing an initial blast, releasing the heat transfer fluid and spraying one of the refrigeration technicians. The boiler room was then seen filling with white mist, followed by a second explosion that resulted in the boiler room wall collapse and fire. When the refrigeration supervisor arrived on site, they were assisted by 2 first-shift refrigeration technicians. The shift changed at 6 p.m., and the refrigeration supervisor was joined by 2 second-shift refrigeration technicians. The refrigeration supervisor and technicians stated that the technicians worked under the direction of the supervisor. In addition, each stated that the supervisor performed the work and the technicians watched and gathered tools or parts as needed. The refrigeration supervisor stated that after they installed the new coupling on pump 1, they aligned it using a micrometer. Interviews indicated that the pump was not aligned using any tools and was eyeballed. Employer training states that the shaft coupling will be aligned using either a straight edge and feeler gauge or a dial indicator. Witnesses indicated that neither of these methods were used on December 26, 2024. In addition, the employer training and equipment training manual state that both a cold alignment and hot alignment should be performed following a coupling installation. It was stated that a coupling was changed out on pump number 2, adjacent to pump 1, a few months ago. A document provided by the employer shows that the couplings were requested from the parts department 3 times in 2024, February 16th, December 9th, and December 26th. The technician who had changed out the coupling on pump number 2 on December 9th stated that they do not do alignments when they change the coupling. A third party would come out and do that. They stated that they had assisted the refrigeration supervisor in changing couplings, but had never seen them perform an alignment or perform one themselves. The refrigeration maintenance staff performed checks on the boiler system every 2 hours where they checked temperatures and pressures and looked for anything out of the ordinary. This typically included looking for leaks and listening for any unusual sounds. The staff also performed more detailed inspections every 2 weeks as part of their preventative maintenance program. After reviewing the daily and weekly PM information and discussing the inspections in interviews, it was determined that they did not specifically pay attention to the flex joints in the system. The employer provided a Fulton training document used to train the staff that stated, "Closely inspect all flex joints." The CSHO obtained information from Georgia State Fire Marshal's Office, Arson Unit, local first responders, and consulted with the OSHA Hazard Response Team. Based on this information, on-site inspection and interviews, it was determined that a flexible hose carrying the heat transfer fluid located above pump 1 ruptured. According to the refrigeration supervisor, the flexible hose was original to the system and therefore 25 to 30 years old. Pump number 1 had not been aligned per manufacturer recommendations, cold and hot alignments, prior to being put back into full operation, likely causing excess vibrations. The pump number 1 bracket was broken on December 26, 2024, causing the pump to shut down, potentially due to excess vibrations. Pump vibration issues in the age of the flexible hose may have contributed to the hose failing and subsequent explosion. That is the end of the narrative report, and just a few comments on that. So essentially, called in on December 26th, which I assume they were not working on December 25th, which is Christmas Day. So once the pump, thermal fluid system works just like a hot water system. If you don't have pumps running, you're not going to have any movement of the oil, at least any serious movement. You may have some movement just from heat, but when the system cools off, that movement's going to stop. So the pump had shut down. Typically, it's probably there's nothing on a pump that is going to shut down based on vibration. I highly doubt they would have like vibration monitors. It's more likely that either the motor tripped on overload, or I would guess that since they changed the coupling, that the coupling tore or was damaged and the motor became disconnected from the pump, and now the pump is no longer turning. So you're not going to have any fluid movement, and the heaters are going to shut down because there's no differential pressure across the heater. The Fulton thermal fluid heaters have differential pressure switches to monitor flow across the heater. So the original thermal fluid units were installed in the 90s, and that would make the flexible joints 25 to 30 years old. I do not know what the typical lifetime of the flexible joint is, and I don't know if the flexible joints used on a thermal fluid system are a different material than used on just a hot water system. I assume they're just rated on temperature, but and can handle fluid. Thermal fluid isn't like an acid, so there's no like corrosion issues there, but it's probably just going to be on temperature and pressure for the selection. That would be my guess. And while the vibration isolator, and if you don't already know, so on a pump, typically on the discharge side of the pump, you'll put a vibration isolator. And in this case, it is a tube between flanges. I believe that they are 6-inch flanges, but it is a tube. And then there's this mesh that is woven around the tube. The vibration isolator helps with movement, thermal movement, and vibration isolation. So you don't want the vibration of the pump translating throughout your piping system. So that isolator will remove the metal-to-metal contact and will dampen vibration, and then it will also allow thermal movement of the pump and piping so that you're not putting pressure on the pump. The isolator, they're not meant to help with misalignment. They can do very, very little misalignment, but a common misconception is that because the isolator can move, that you can move it all over. You want it to be installed in a no stress state. If you're having to stress and pry over a vibration isolator to like get the flanges aligned, you're already doing something wrong. That is not what they're meant for. But in this case, it was installed 25 to 30 years that we know of. So I would assume it was installed correctly. However, the vibration from a bad pump or a bad coupling, that vibration, while it can seem very minor, when you're spinning a pump at 1800 or 3500 RPMs, that vibration constantly over hours and hours of time is going to wreak havoc on the pump and any parts surrounding it. And it's not clear what broke on the base of the pump. The refrigeration supervisor welded a bracket. I don't have any pictures of that weld or that bracket, so I'm not clear on what broke on that. But if a weld or metal comes apart on a pump or a pump base because of vibration, it's not because that you had bad metal or a bad weld. There is an issue with vibration that needs to be corrected before you just weld it up again and send it. Welding it up again is just going to cause the same issues. So, but it is not clear from this report what that issue was, but I'm going to guess that the broken bracket on the base of the pump was caused by vibration. And then the coupling was also ripped apart by vibration. And the alignment is critical. So when you align a pump and coupling, so the two shafts point at each other, and I believe there's 3 types of alignment. I'm a little rusty on alignment, but essentially the shafts have to be perfectly parallel, so in line with each other. And then height-wise, they have to be the same height. And then they have to be also like front to back in a line, which it should essentially be like one shaft with a coupling in the center. And if you have wrong alignment, it causes stress on the coupling, and couplings have tolerances, but the tolerances are a couple thousandths of an inch. So it's not like you can eyeball the pump alignment. Now, it does state the report that the refrigeration supervisor aligned it, but the technicians state that they didn't align it. Not sure who is telling the truth or what happened there, but I'm going to assume that even if it was aligned, that it was not aligned properly because the vibration was probably still happening, and that's what it caused the vibration isolator pipe to eventually fail. So when you have a ton of vibration through that pump, it's going to transfer that to that vibration isolator, and the inside probably tore. And then from the pressure, it stated that there was an initial blast. So that vibration isolator is this like woven steel mesh thing. And that hose essentially made a big U and broke open, which would release 500-degree thermal fluid oil right to atmosphere. This Parafirm NF has a vapor pressure, I believe it's called, I'm blanking on that, but of 300 degrees. Essentially, anything when the oil is heated over 300 degrees, it'll produce explosive vapors that can cause an explosion. So when this hose broke, you had and I assume the pump was still running, you had a large amount of oil that was released to atmosphere. So we went from 40 to 50 psi to now nothing. So the pressure dropped on the oil, and that is going to cause especially if it's spraying the oil to atomize into the air. And this said that there was a white cloud. So that white cloud is essentially droplets of oil and vapors, and those vapors found an ignition point. I don't know if that could be just they were sucked into the thermal fluid heater and there was that fire, or if it just found a hot pipe. But that vapor cloud ignited, and that caused the second explosion, the first being the vibration isolator pipe to break. And that explosion knocked down one side of the wall of this boiler room, which then crushed the sleeper of the semi that was next to it and killed the person inside that semi. And then two of the technicians were near the area, and I believe one of them had over 50% burns on their body, but both lived. And then I believe that there were some other minor injuries that were not specifically reported on in this report. So that is the narrative report. That is basically what happened. If you want to see the pictures, you can go to boilearn.com, go to articles. There are pictures there, and I have this report as well as some other thoughts. I will now summarize the worksheet details. This is essentially what the employer was cited on, and it kind of goes back into what I just read in a more formal format. But essentially, it noted that visual inspection of the entire system for leaks, make repairs immediately, closely inspect all flex joints. Flexible joints were not specifically noted in inspections performed at the facility. So when the refrigeration technicians were inspecting the thermal fluid system every 2 weeks, they weren't particularly paying attention to the flexible joint. It is unknown if the flexible joint was showing any signs of failure on the outside. Typically on the flexible joint, how they're wrapped, they can cause or show failure if that wrapping and metal mesh starts to bubble a little bit. But I would suspect that the failure was pretty abrupt and it tore from the inside and ripped apart the joint all in a pretty fast manner. But that is just speculation. It could have been already compromised and shown external failure, but there's no real way to inspect a flexible joint without looking at the inside of it. And from just talking to other people, flexible joints do fail, and it is not uncommon to just change the joint in intervals because of the inability to really see external failure that is going to be happening internally on the flexible joint. So if you're going to be taking it out just for inspection, you might as well just change it. And, they're cheap enough as they are to just change it out with new and know that it's new, and you're not looking for a tiny tear. You're essentially relying on a human element to see a flexible joint that is failing without without cutting it apart, which is pretty high task to ask for. And then also the training from Fulton, which was the manufacturer of the thermal fluid heaters, said cold alignment for operation of the pump and then hot alignment when the pump is operating at temperature. That is essential. So cold alignment gets the pump and motor basically close enough. And then as the system heats up, in this case, it gets to 500 degrees, the metal will move, the pump will move. It will not be really visible to you. You'll say, wow, it moves. We all know that, hopefully we all know that metal moves when it gets heated from expansion. And also as it cools, it will also contract, but it will expand when heated. So if you align a pump at 70 degrees and then you align it at 500 degrees, the pump will have moved. And since the pump is going to mostly be running at normal fluid temperatures, which in this case can be 500 degrees, you're going to want to hot align the pump, but you need to cold alignment in order to get it too hot. So the cold alignment is the good enough alignment. And then hot alignment is to dial it in and make sure that you are correct in your alignment. And then you want to recheck it to make sure that you're not having issues with your motor or pump on the feet or the coupling. And that was all from a training presentation. And in the employer documents, they essentially said, hey, every pump needs to be aligned. That's great. I will assume that this training happened once and the employees signed off that they were at the training. That doesn't mean the training didn't work or wasn't valuable, but when companies view training as a thing that to like check off and do versus an ongoing process, this is kind of what you get of, hey, you went to this training, here are the documents, and then the documents get filed away into like the company safety processes. And unless there's like a continual process of checks and balances and improvement, it is very unlikely that those training documents are going to be referenced again. And also, if you don't have those checks and balances, how do you know that the employees that were trained are actually doing what was in those training documents? That's why training is a continuous ongoing thing. And then also like, hey, we just hired a new person. They also need to be trained as well. And that's why I would constantly recommend that internal training happen. While that's very difficult, but you also in this case, a pump alignment, if you have a laser alignment system, which is essentially two electronic laser type systems that get attached to the shafts of the motor and a shaft of the pump. And when you turn it by hand, I believe you got to turn it like 70 degrees, 80 degrees or whatever. And you can get, it'll tell you on your display, on your readout, what the misalignment is and how to correct it. And then you can also create a report from that. And that report essentially proves that, hey, the alignment was done correctly and it can't be fudged. If you have a manual report where people are using manual tools like a caliper and feeler gauges, you can fudge a report and, pencil whip it, as they say, to say, hey, yep, it was manually aligned properly. And I will say, unless you're aligning pumps all the time, the laser alignment system, while it takes an initial training of like to get used to, it is way faster to laser align than to do it manually, because essentially every movement you make of the pump or motor, it affects other measurements. So it's not like you can just move the pump over one way and now it's good. You're constantly changing the measurements of your misalignment. And a good laser alignment system will tell you how to change, like, hey, the back side of the pump needs to be kicked over 5 thousandths or whatever to bring the shaft in alignment. And it does all the math for you. It is way easier. And like I said, unless you're aligning pumps all the time and you are taught the old school method, a laser alignment system, way easier. And also it can create reports, which are essential for a facility that has multiple employees and needs to track that things are actually being done correctly. So essentially the employer was cited that they didn't furnish an employment place that was free from hazards and didn't properly train the employees to align the pump, and that they were exposed to explosion fire hazards. The fine was, I think, a little under $17,000, which dropped in the bucket for a facility like that. But once again, OSHA really isn't, they're not a court case. A lot of people think OSHA fines should be millions and millions of dollars. There's a whole fee structure set up, and OSHA doesn't just walk in and feel like, oh, this caused a lot of damage, we feel like we should fine you $5 million. That's typically just lawsuits that get into that. OSHA has fee structures, and it's a very structured setup. And the whole point of OSHA is to like try to get employers to care about safety. Some do, some don't. But in this case, I'm not going to say that Tyson Chicken was negligent, this just seems like you can always say that people can be trained more, but at a certain point in time, you have a job to do, and how are you going to, it's like it's chicken and egg scenario. People have to be able to do a job, and it's not like you can hire somebody and get them 10 years experience to get them to always do something perfectly before they do experience. At a certain point in time, somebody's going to be working on a system that doesn't have a ton of experience or all the training they could get. So I'm not going to say like that Tyson chicken was negligent. I don't see that from this report, that they, the supervisors, whatever, of the Tyson chicken went out of their way to make sure that this would happen, or were like cutting costs. This just seems like a breakdown of checks and balances and inspections and production above everything else. I'm sure they were starting up from Christmas. They couldn't get it going again, called in the refrigeration supervisor. He got the pump going and wanted to get the production manager say, yep, fryers are online. Yep, we're good to go. Maybe it'll make it to next week where we can call in our pump alignment contractor. The report did say that the outside company does align the pumps. So maybe he thought it would make it a week, or, hey, we got to do this. Like, there's a lot of details that were not explained in this report, and I'm not going to just speculate and say, oh, well, this person's at fault, that person's at fault. There's a little bit of fault on all sides. Unfortunately, this event did result in a fatality and two people getting burned, which is unfortunate. And hopefully we can learn from this. But once again, eyeballing a pump is not good enough. There's always going to be a tiny bit of vibration just from how a motor runs and how a pump runs. Anytime you have something turning, there's going to be vibration. But that vibration should be very, very minimal. I don't know how to explain what minimal vibration is, but if you've been around a pump that's vibrating or a motor that's vibrating, you will know what good vibration is versus bad vibration. If you can like set a tool vertical next to the pump and that tool doesn't fall over, you're probably pretty good. If that tool and like tools move next to the pump and like vibrate, you're definitely way bad, and you're not going to have a long life on that pump. Typically a bearing, if you don't have a misalignment issue, a bearing issue on the pump will also cause a lot of vibration. I've also, in this case, they're Dean pumps. I've seen Dean pumps, the bearings lock up and bend the 1.5-inch shaft in a 45 degrees. So there's a lot of force getting transferred from the motor to the pumps. And when bearings lock up, when the pump is turning at 1,800 to 3,600 RPMs, that 1.5-inch solid steel shaft can just bend over. And yeah, that's just keep a reminder that incidents like this happen. You are not immune from incidents like this happen. And I'm sure the refrigeration supervisor thought he was doing the correct thing. And yep, we're getting it online. Yep, the pump's ready to go. Yep, we can do production. And maybe he knew that the vibration wasn't right. Maybe he didn't. I'm not sure. But that little lack of oversight ended up causing the vibration isolator pipe to rip, which then caused the thermal fluid to leak, and which caused the explosion, which caused the walls to knock down. It ruined the whole boiler room. They ended up rebuilding and ordering a new system. So they are back up and running. But yeah, just keep that in mind. If you want to see the pictures or read more of the details, you can go to boilerin.com and go to articles, and you will find the article there. I would appreciate if you had any thoughts on this. If you could send them to me, either DM me on LinkedIn or email me eric.johnson@boilerin.com. If you have any lessons learned that were similar to this, or anything else, near misses that you're like, hey, this would be a good story, you can always reach out. Let me know. I'm always trying to give people perspective on what happens and what can happen. And in this case, this whole unfortunate event and how it happened just ended up being from excess vibration on a pump, which nobody would ever think that would cause a large explosion and a fire and walls to knock down and ruin the whole boiler room and all the equipment. That's not what people think when they change out coupling on a pump and motor and say, oh yeah, this is going to lead to a domino effect and cause this giant fire. Most people are just in the moment, getting production up and running. Yep, good enough, and then leaving. And if you have this perspective and maintain this perspective of you need to do things correctly, and sometimes you have to say no and nope, like let's slow down, let's do this correct, let's do this safely, and this is not safe to run, you can prevent events like this from happening. So if you enjoyed this podcast or any other podcast, please once again rate the podcast 5 stars. It takes 1 minute on your podcast app to do. Please, please, please. Goal is to get to 25 stars for Spotify and Apple. If you listen on YouTube, please subscribe to the channel. I'll be putting out a couple more videos soon. And if you're listening to this before AHR, I will be at AHR. Hit me up. This is coming out January 29th. So AHR is in a couple days in Las Vegas. But I appreciate you all listening to this podcast. Let me know if you have any guest suggestions or topic suggestions. Stay wild.